Welcome to a lesson with Dr. Powell. Let's take a look at how we can find the area in four-dimensional space of a parallelogram formed by two vectors. We can align these vectors either as a row or as rows or columns. Let's just do by rows. It doesn't matter which way we do it. Let's see, suppose we have something like 1, 0, negative 1, 2, and maybe we have 1, 1, 3, negative 1. All right, so what do? Well, we simply just list out all possible 2 by 2 submatrices, and we think of it as the square root of the sum of those squares. The projection onto the different axes, the different planes that we get happens by these 2 by 2s, and they will be oriented, but we won't care about the orientation when we square. So we just take the determinants and square, for instance, this one, so we can look at all different combinations, perhaps just different ways of selecting 2 at a time. So let's pick these 2 for beginners, and the determinant's 1, so we get 1 squared. Maybe we'll do this one and this one. Determinant would be 3 minus a negative 1, so it'd be 4 squared. And then we have this one and the last one, so we have negative 1 minus 2. So it'd be 3 squared. And then, okay, so that was all combinations with this one. Then we move to this one right here, and let's see. We've already used up what's before it, so we do this one and that one. It's just 0. It just looks like plus 1 squared. And then this one and this one looks like a 0, so just 2 squared. Okay, let's move to the next. All right, let's move to the next. So we do that. Let's move to the next spot. Okay, so the only one we haven't done is this one and this one, which would be 1 minus 6. So it looks like we get 5 squared. Okay, so we find this, which we can compute as 1 plus 16 plus 9 plus 1 plus 4 plus 25. So we get what? So we get what? 20 and 30, 31, and 56. Let's just check. Okay, so that's 20 and 10, so 30, 31, and yeah, 56. Okay, so it looks like the square root of 56. All right. Now another way we could have done this, actually, what if we just multiply this matrix by this one? We have 1, 0, minus 1, it's transpose. 1, 1, 3, minus 1. Okay, so this means take first column, subtract that column, and then add. See, I'm just going down this list, then add 2 times the last column. So this minus that, so 1, so it looks like we have, so we got 2 minus 2, or maybe I'll just do it regular way. Okay, so we have 1, 0, okay, and then we have 1 and 4. So it looks like 1 plus 4 is 5, plus 1 is 6. So we have 6 right there. And we do the same thing here. Okay, so we have 1 minus 3 is minus 2, and minus another 2. So that would be negative 4. Okay, and we do that and that. So we get 1 minus 3 is minus 2, minus 2 minus 2, and we have another negative 4. Okay, and then do this again over here. We get 1, 1. Not, I said 1, 1, that's 2, it's 9 is 11, plus 1 is 12. Okay, now if we take the determinant of this, we get 72 minus 16, which ends up being exactly 56. Then if we square root that, we get the same thing. Notice what we did. If we take this and then multiply by its transpose, we also get the square of the area. The same result actually happens by just looking at the determinants and one by one and squaring them and taking a square root. It's kind of like this generalized Pythagorean theorem type of idea, a fancy way for finding the area or volume, if you will, of something of any dimension given between certain, that's defined between certain vectors. Thanks for watching.